Hey everyone, welcome back. What I want to talk about today is I've been playing around with some assembly language programming, as you know from watching my previous videos, and the last program that we took a look at wasn't really structured very well, so I've been working on another program that I want to share with you today, and we'll take a look at how I structured it, and we'll see how it looks compared to the other one. So I've tried to make this program a lot more structured, and it's, I think, a lot easier to use, and I'll just show you how I did it, and you can see if maybe it's something that will be helpful for you in your programming journey as well. So before I change and show you my screen that has the program on it, I just wanted to let you know why I've decided to make another program and go over another program with you. I think now I've learned enough techniques that I should be able to make at least a simple game. So that's what I've done here. I've just tried to make at least part of a simple game. I haven't made an entire game yet. I just made the beginning of the game just to kind of get a feel for it and see how I could do. So at this point in our journey, we now should be able to load values into Z80 registers, and we should be able to transfer data back and forth between memory addresses and registers. And we learned how to print both text and numbers onto the screen. And I think we looked at how to change the attribute values for the screen as well. So now we can print both characters and numbers on the screen in whatever location we want. And we can print these characters and numbers using different print attributes, different colors for the paper and ink and flash and all that. So I think that's a good start for us to be able to at least begin making a program. So the program or the game that I wanted to begin making is an adventure style game, which is going to use both text and simple graphics. And we learned how to print characters on the screen, both as individual characters and also as parts of strings of characters. But what we haven't looked at yet is actually printing user-defined graphics. And user-defined graphics is not a complicated topic, but we just haven't covered it yet. But I'm thinking, since we're able to print characters on the screen, why not use user-defined graphics characters, which we can program ourselves, and we can actually print little graphics instead of using just the alphanumeric characters that are part of the Sinclair Spectrum character set. Actually, I was debating with myself whether or not I should make a video covering user-defined graphics, because they're a very primitive way of using graphics, and I wouldn't actually call them user-defined graphics. If it were up to me, I'd probably have called them like user-defined characters, because you can change the look of the characters. And I'm sure many of you are already familiar with user-defined graphics. And so anyway, I'm not going to be covering user-defined graphics today anyway, but just as a kind of a heads up, as we move forward in this game that I'm making, as I continue to work on this game, and when I get to the point where I'm actually printing graphics, then I'll probably look at user-defined graphics at that point, because we haven't learned how to print any fancy graphics yet, so we have to start somewhere, right? So for today, the part of the game that I've made so far is a very introductory part, and all it does is print a welcome message on the screen. Well, it does a couple of more things than that, which we'll see when we take a look at the program. For example, it changes the border color and the paper color, but not just the paper color of the characters that we're printing, it changes the paper color for the entire screen. So it clears the entire screen, and we'll go through that and I'll show you how I accomplished that. And so we're going to look at those as well. So in this program, it's actually going to cover a bit more than we looked at in the previous videos, because we're also going to be looking at a couple new ROM subroutines that are very useful for us. So I think that's enough talking for the introduction, and I'm going to share my screen with you now. Okay, well, apparently I can't change the camera mode on my recording software in real time, so this is going to be two videos edited together, but that's okay. At least I'm getting closer to my goal of the one-take video. I don't know if I'll ever get there, but if you watched any of TJ Ferreira's videos, he's really the master of the one-take video. when he remembers to press record on his camera, that is, which it seems like he always does. But that's my goal, is to get to the point where I can record a video in one take like TJ does. And just to make this video a bit interesting, I'm going to find a video on his site that I think is interesting and cool, and I'm going to put a thumbnail of it on this video here somewhere. So if you haven't heard of TJ Ferreira, then that's pretty unbelievable if you're in the ZX Spectrum community, because he has a fantastic group called Sinclair Society, and he has his own YouTube channel, and he's just a really fun character. So go go check him out. Check out his YouTube channel and his Facebook groups. And if you're interested in Intellivision Amico stuff, he's also got an Intellivision Amico group as well. So go check him out if you like. But he was my inspiration to try and reduce the edits in my videos to hopefully get down to a single take. And we'll see how this goes. So now let's take a look at this program that I've been telling you about, which is my first attempt at a real game using Z80 Assembly Language from the techniques that we've looked at in my videos so far. And if you've been following along with my videos in order, my videos are actually in order. I try to go through them in a progression, starting from the more elementary information that I think is kind of the foundation that we would need in order to make games and programs. So if you haven't been following my videos in order, you don't need to watch them all in order, and of course it depends on what your experience level is. But if there are topics that are general computer topics in my video series, then I just want to let you know that I've numbered each of my videos in order. And of course you can skip some that refer to topics that you may not be interested in, but just take note that all my videos are numbered, so I try and go in some sort of progression. So now I've really been talking too long, so let's take a look at this program now. So let me increase the size of the text so we can see it properly, or see it better. And again, I'm using the ZX Spin development environment, which I've been using so far for most of my programming videos, because it's a super easy environment to use. And even though it doesn't it's not specifically designed to emulate the ZX Spectrum Next, you can see for this initial stuff that we're doing, this kind of introductory Z80 Assembly Language programming, and even the machine code programming we did, where we actually programmed in machine code, and everything that we've done in this environment so far, it's such an easy environment to use. I really recommend, if you don't already have a better setup and you are looking for some way to make assembly language programs, or even basic programs for the regular Sinclair Spectrum computers, I really recommend you check out this ZX Spin environment, because it's super easy to install and super easy to use. And I keep showing you guys the links to install this development environment, just because I've been so happy with it so far. So I really recommend that. And now let me go ahead and change my font. So in this assembler, I like this Consolas font here, Consolas, whatever, and I'm going to pop it up to maybe size 16. Okay, so that should be big enough for us to see now. Let me make my window a bit larger here. All right. So now the purpose of this game that I'm, this portion of the game that I'm making, this part of the program, what this program is designed to do is to just, as I said before, print a welcome message on the screen. I think I said that before. Hopefully I said that before. So first of all, let's take a look at the structure of this program and see how I've laid it out. And we should be by now familiar with almost all of the parts of this program, because we covered these in previous videos, except for a couple of the new ROM subroutines that we're going to be calling, and I'm going to show those to you as well. So first, let's just go through this program, hopefully somewhat quickly, because it should be information that we pretty much know by now. But I want to show you how I've laid it out here using the techniques that we've learned so far. So what I did is I tried to lay out this program in a very structured way, and I keep talking about structured programming, which is also modular programming, which is dividing up our programs into small pieces that can be tested individually on their own. They are self-contained subroutines, and it's just, I think, a really fantastic way to create a program because it's very easy to write and troubleshoot and maintain and test and all that. So let's see how I've done it. So here at the top we have our org instruction that we're all familiar with now. This will tell the assembler where to store our machine code program in memory. In this case, it's going to store it at address 35,000. And this top line of the program here is a comment, which is just the name of the program. My program is called Mystic Maze, copyright 2021. Oh, and you can see up here, the name of the program is also Mystic Maze, but it has a little star after it. So in this assembler, the star means this version of the program hasn't been saved. So maybe I should go ahead and save it now. So I'll click File, Save As. And here I've got some other programs that I've saved, so I'm going to just re-save it over an existing version of this game that I've saved before. So there, now the program is saved, and I no longer have that little asterisk mark after the name of the program up here. And now let's take a look at how I've divided up my program. And you can see these messages here, these comments that have these strings of asterisks in them. I've used those to split up the major sections of my program. So here you can see I have a section called main program loop, for example, and then another section called subroutines, and we'll take a look at the different sections individually. But this main program loop here, this is where the program calls all the other subroutines in order to perform these functions of this modular program, because each subroutine is a module that is going to be called from the main program loop. Now let's take a look at the main program loop. So here I have just a comment with a label called main, and it just is followed by a comment that says it's the main program loop. And then you can see within this main program loop, these three lines here, all they do is call the other subroutines in this program. And then finally the main program loop ends here with a return to basic. So you can see there's actually no code whatsoever in my main program loop. All it's doing is calling other subroutines. And I'm not sure if it's really possible or feasible to create a program that has no code in the main program loop whatsoever, and it strictly calls subroutines to perform every function. But I'm going to try to accomplish that, and we'll see if I'm able to do that. So let's take a look at the next section here. My next section is called subroutines, and this is where I have the modules or subroutines that are going to be called by this main program loop. And you can see that right here. This line here, for example, calls a subroutine called sub1, and then this one calls sub2, this one calls sub3. And you may be wondering, why am I using these very non-descriptive words for my subroutines? Most people, when they make a program, I think, for example, if they're making a basic program which contains procedures, with the ZX Spectrum Next, for example, you can create procedures, and you can name those procedures pretty much whatever you want. And people tend to name their subroutines something that is descriptive, that tells them what the function of that subroutine is. Like, for example, if we're going to change the border color, like this subroutine here I have, which says set border color, it's going to change the border color using a new technique that we haven't looked at yet. So you're going to be interested to see that, hopefully, unless you already know it. But this one, you can see it, I've called my subroutine, or I've named my subroutine sub1. And the reason I do that is because, for me, I think it's just easier to use these names that are very easy to remember, sub1, sub2, sub3, and I don't really need to remember that way what the actual name of the subroutine is. For example, I might call a subroutine, border color, or I might call it border, or I might use some abbreviation, board CLR or something. So in this way, I don't think it's really going to save me a lot of time to put the descriptive name here, because if I forget the name, I'll have to go and look through my program listing to see what the name is anyway. But of course, you can name your subroutines whatever you want. I'm naming mine in this convention for now, and I'll see how it works out for me. So that is how I've decided to name and organize my subroutines. So if we take a look at this subroutine section here, and the subroutines are arranged in order you can see here's sub 1, here's sub 2, and then followed by sub 3. So I think in general, I'm probably going to create my subroutines in order like this, but that doesn't mean I have to call them in this order. Obviously, I could call them in whatever order the program is going to use them. So don't get too hung up on the numbers. If you're going to number the subroutines like this, it's not important, I think, that the numbers are called in order, because obviously the program is going to call them in whatever order it needs to use them. So let's take a look at the subroutines now. So the first subroutine that gets called by my main program loop is sub 1, which is, and I put a note up here, it's going to set the border color. And then let's take a look at sub 1. So here's sub 1 here, and it's calling it by this label here. So of course I need to begin my subroutine with a label that matches the label that I'm calling in my main program loop. So this sub 1 represents a memory address where my code for my sub 1 subroutine actually starts. And then here's what my sub 1 subroutine does. It's designed to set the border color, or change the border color, to a particular color. And probably what we should do before we look at the subroutines is look at the end of my program, where we have some other information that I've stored in different sections. So here we have our subroutine section that contains the actual code for all the different subroutines. But then let's just finish looking at the different sections of my program. So here you can see there's a section I've called strings, and these are going to be messages or text strings. They're strings of alphanumeric characters or messages or words or whatever I want. They're going to be messages that get printed to the screen in my game. So I've got a separate section just for messages. And we'll take a look at that in more detail in a minute. But then down here, after that, we have a section I've titled values. And this values section is not where I'm assigning values to particular labels, as we looked at in a previous video where we talked about how we can kind of duplicate the functionality of variables in an assembly language program. In this case, you can see this value section. It contains these lines of instruction that use this define byte instruction or assembler directive, which stores bytes of data into memory locations. So just as a bit of a quick review, this define byte instruction here will store a value of 0 right here into a memory location that is pointed to by the label here called health. So this health label will automatically get assigned a value by the assembler when it gets assembled as the value of the memory location that is storing this byte that I'm saving here. As the same thing will happen with these other two labels here. The strength label will contain a value of a memory address that stores this byte here, and the gold label here will contain a memory address which contains this byte that's being stored after it as well. So you can see in this case, I'm using define byte to store 0 values for all of these different 3 attributes. So I haven't actually included functionality in this game yet to actually use the player's health or strength or gold values. So for now I just assign them as 0, just so I would have a section in my program to store values that I'll be assigning later that I want my program to keep track of and to adjust as the game gets played. All right, now let's take a look at the next section here, which is called ROM routines. Now this is a section where I'm assigning values to labels. And the reason I'm doing this is because ROM routines are, as you probably know, these are subroutines that exist in the ROM memory of the computer that are designed to perform a certain function. For example, if you look here, this top routine that I'm calling, my message says ROM routine to print string. So there's a ROM routine in this case that we're going to use that prints our string of characters on the screen. And our next ROM routine here says activate output channel. So as we looked at in a previous video, when we want to print to the upper part of the screen, we have to activate that as an output channel. So that's what this ROM routine does. And I've called that one outchan. So I've kind of labeled my labels or named my labels with descriptive names that tell me what these subroutines do. So this top one is called print str, which stands for print string because this ROM routine prints a string. This outchan label is going to point to a ROM routine that activates the output channel. And then now here are two new ROM subroutines that we haven't looked at yet in my journey of the videos I've been making. So this one here that I've called CLS, which is short for clear screen, it's going to clear the screen for us. And also there's another note here that I'll just let you know about. It says ROM routine to clear entire screen using attributes in attr-p. So I'm going to explain this in detail later when we look at this subroutine, but just to let you know, attr-p is actually the name of a system variable, and I'll explain more about those in a moment. And then finally we have this ROM routine called border, which sets the border color. And so all I'm doing here is assigning these memory address numbers to these labels so that I can utilize the label names in my program instead of having to remember these actual numbers where these ROM routines exist in memory. And the next section of my program here is called system variables. Oh, that's what I just mentioned a moment ago. So this attr-p is a system variable. And I guess I should just describe what system variables are now since we're talking about it. So as you probably, I'm sure many of you already know, the Sinclair computer has something known as system variables. And these are actually memory locations that contain values that have a meaning. And so for example, if you look here, this note here that I've made for this system variable that is called attr-p, and I've said sysvar here. So this is a sysvar or system variable that has a name of attr-p. And how system variables work is that the computer uses memory addresses to store values that represent something. So for example, this attr-p system variable is a memory address that stores a value which tells the computer what the attribute values are for the computer at the moment. So for example, that includes the paper color, the ink color, and the flash attribute and the brightness attribute. So whatever value is stored in this memory address, which in this case is 23693, and I'll just see if I can bring up that system variable in a manual here. So if I bring over this manual, which is, we'll just take a look at the cover, which is, this is the ZX Spectrum basic programming manual that comes with a Sinclair Spectrum computer. So in this manual, there is a section, if I just scroll down here to where? Right here. The system variables on page 171. Page 171. So here is the section on system variables. And you can see here that it contains memory addresses right here in this column, along with names in this column. These names that are applied to these different system variables, they're not names that we would use anywhere. These names don't mean anything to the computer, so we wouldn't use these system variable names in a basic program or an assembly language program. It's just a name that we use to refer to this particular system variable. And so each system variable has an address where the value for the data is stored, and they have a name. So if we look for the system variable that I'm interested in, which is, let me go back to my program here, which is attr-p, which should be at the address 23693. And I'll just go back to my manual here, and I'll look for 23693, which is right here. There it is right there. So the system variable name is called attr-p, and the address of that system variable is 23693, which means that this memory address is going to contain a value that represents the attributes. And all of these different system variables do different things. And you can see here, for example, the description tells you what they do. And this one, for example, it says permanent current colors, etc., as set up by color statements. And the color statements would be if you manually change the border color or the paper color or whatnot, it will adjust the value in this attribute memory location. And we can also take a look at that here. If I look at my notes here, I'll just bring it over, you can see that this graphic here shows us how to calculate the value of the attribute that would be at this system variable memory location. And we've looked at this before in a previous video, but here is a single byte of data that represents all the bit combinations that make up the different colors that we use and attributes that we use. So for example, it contains bits that represent the paper color, the ink color, and the brightness and the flash values. And this is the formula here that we use to actually calculate the value of these bits. So we use a flash value, which is either 0 or 1 multiplied by 128, and then brightness, which is either 0 or 1 multiplied by 64, and then the paper color multiplied by 8, and then the ink color, and we add all of those together and we get a total value, and that is the value that gets stored in this memory address, which this system variable is called ATTRP, and so that's why it's using this particular address, because that's going to store the value of the attributes for the computer. So now we know how the system variable works, and we'll go back to my program here, and now this line should make sense. So this number that I'm assigning to this label called ATTRP is simply the memory address that the computer associates with this system variable. And so now let's take a look at the next or the last section of my program, which is called control codes. And this section of the program I created pretty much specifically just to make my life easier for convenience. So in this section of the program, I'm assigning specific values to labels that will help me to create my program without having to remember numbers. For example, in our previous video, we took a look at how we can print to the screen, and when we print characters on the screen, we can also print control codes to the screen as well. For example, if we take a look here at the character set for the Sinclair Spectrum computer, I'll just go up here to this section here that's called ASCII codes. So we took a look at this before, but you can see here from our character set, each character has its own code assigned to it. For example, the space character here, the space character has a code of 32. This exclamation mark has a code of 33. And we looked at this before, but each of the codes represent either a printable character, or some of them also represent non-printable control codes that we can use. And for example, these codes here, code 16, 17, 18, 19, 20, they refer to the ink color, the paper color, the flash color, the brightness value, and all that. So we can actually use these control codes to change the attributes of the characters that we're printing. So I'll just move this back. So that's what I'm doing here. So in this program, I'm going to be using control codes to print characters on the screen with particular attributes, like changing maybe the paper color or the ink color. So instead of having to remember the control codes, let's say for ink, I can just go down here and I've assigned a value of 16 here to this label that I've titled ink. So now if I want to specify an ink color in my program, I don't need to use this number 16. I can use this label ink, which is a lot easier to remember. And I've done the same thing here with different attributes: paper, flash, bright, and even the colors, the individual colors. And we're going to take a look at this in detail in my program in a moment. But you can see here, down at the bottom, I've assigned the individual color value numbers to labels that correspond to the colors as well. So now I can just use these labels in my program rather than the numbers that represent the colors. So those are all the different sections of my program, and the different sections are actually a lot longer than the actual program because I've set it up in this modular way, so it's easier to maintain, but it's just takes up more space than it would if I just mashed all the code together, I suppose. So let's take a look at how easy it is to both execute and test and create and modify this program now. So now let's go back to my subroutines, and the main program loop here, first of all, it's going to call my subroutine that I've titled sub1, which is right here. And sub1 is going to set the border color. So how is it going to set the border color? Let's take a look right now. The first thing it's going to do is load a value into the A register right here. And you can see the value that it's loading is a value that represents this label that I've called BLK, which stands for black, which is what we just took a look at down here. I've set a value of 0 to this label called black. So 0 is the number that represents black. So in this subroutine here, I'm loading the value of 0 into the A register, but I'm using the label that I've called BLK to do that, so I don't have to remember that the number for black is 0. I'm just using the label that I've set up where I've loaded the value of 0 into that label. So that's, I think, kind of a handy thing to do that I'm probably going to do for all my programs where I use colors in them. And then let's take a look at the next line here where it says call border, and it says ROM routine to set border color. So if we go back down to my section here that's titled ROM routines, you can see there's one here called border, and what it does is it calls a subroutine in the ROM memory which lives at address 8859 right here, and that subroutine sets the border color. And if we go back up here to my subroutine we were just looking at, so this subroutine calls the border subroutine, or this subroutine that I've assigned a label of border. And the way this subroutine works is very simple. All you have to do is load the color that you want the border to be into the A register here, and then call that subroutine. So when we call this subroutine, it's going to change the border color to whatever number I've stored in the A register, which in this case is black. Now let's take a look at my next subroutine, which is this one here, sub2, because you can see that's the next subroutine that my main program loop will be calling. So after subroutine 1 executes, it's going to return using this return statement, and it's going to return back to the main program loop right up here to the line after the one that called it. So in this case, it's going to call subroutine 2 next. And my note here says that this subroutine clears the screen and sets paper color. So now what we're going to do is make use of another ROM routine which clears the screen. So you may be familiar with the basic instruction CLS, which stands for clear screen, which clears the screen. And there are a few different methods of clearing the screen, just so you know. And I'm just going to introduce you quickly to those now, because I like to keep records of all these different subroutines that I find. And so if I bring over my notes here, you can see that I've got a section in my OneNote program here that's called ROM routines. And so I'm keeping a record of the different ROM routines that I come across and that I experiment with, and I think will be useful for me. But let me just zoom in here so we can take a look. So here at address 3435, there is a ROM routine that performs the function of clearing the upper screen. And we discussed in a previous video how the Sinclair Spectrum screen is divided into an upper part, which is the larger part, and then the lower part, which contains just the 2 lines where the computer prints messages and also where we enter instructions, for example, when we're creating a basic program. So in this case, there is a ROM routine that lives at address 3435, but it only clears the upper portion of the screen. It doesn't clear the bottom 2 lines of the screen. So in this case, I want to clear the entire screen, both the upper part and the bottom 2 lines. So I'm not going to use this subroutine. Instead, I'm going to use this subroutine, which lives at address 3503. And you can see my note here, it says it clears the entire screen, including the bottom 2 lines. And then I've also got a note here of how it works, but let's take a look at how it works in my actual program. There. So now we're in the subroutine that's going to clear the screen. And what I want to do is, in my previous subroutine here, I've already set the border color to black, and now I want to set the inside of the screen to black. I want the entire screen to be black. So now I need to clear the screen and set it all to black. So the way I'm going to do this is this subroutine that I'm going to call, which is right here, call CLS, which we took a look at briefly before, is right here in my ROM routine section. We have a line here called CLS, and it has a value of the ROM routine that clears the screen. So we're going to be calling that subroutine from here. But when we call this subroutine, what it's going to do, it's going to clear the screen, and it's going to use the attributes that are stored in the memory location that is pointed to by this ATTRP system variable that we looked at before. So we now know that this system variable ATTRP, which we can look at down here in my system variables section of my program, I've assigned it a value of 23693. So that is the actual memory location that stores this attribute value that this subroutine is going to use when it clears the screen. So when it clears the screen, it's not just going to make it all like white paper. It's going to look at whatever value is stored in this attribute P memory address, which is 23693. And whatever value is stored in that address, it's going to use that value to color the screen. So if I put a value in there that tells the computer that the paper should be green, then when it clears the screen, for example, the paper is going to be green. So let's take a look at my subroutine and see how this works. And so what I'm doing in this line here is I'm assigning a value to the HL register pair, which is going to be the address of this ATTRP system variable. And the reason I'm doing that is because I want to load a value into that memory address that will tell the computer what colors to use, and I do that right here. So in this line, I'm loading a value into the memory address that's pointed to by the HL register pair, and the value I'm going to load into it is BLK times 8, which will set all the attribute values to 0 except for the paper color. Well, actually it's setting the paper color to 0 as well. So because black is the color 0, if you look down here in my section at the end here where I've assigned a value of 0 to this label called BLK, it just is a coincidence that black happens to be 0. But the way this subroutine works is it's assigning a value to this memory location, which is a system variable memory location. And in this case, it's going to assign a value of 0, which means all of the attributes are going to be 0. The ink is going to be 0, the paper is going to be 0, and the flash and attributes are also going to be 0, which means they're going to be disabled. So the reason I'm using this value of 0 is obviously because I want to set the paper to color 0, which is black, and which is why I've used this black label here. And then when I call the subroutine in this next line here, it's going to clear the screen and use the attributes that I've indicated, which is black. So it's going to clear the screen and make the inside of the screen black to match the border. And then it's going to return in this line here back up to our main program loop up here. And then finally our main program loop ends off by calling sub3, which is right down here. And you can see by my message here, by my comment, it says this subroutine will print our welcome message. And we took a look at in our previous video how we can actually print strings of characters to the screen, and that's exactly how we're doing it here. We are first of all using these two lines here to specify the upper screen as an output channel, and that's output channel number 2. And if this doesn't make sense to you, then you might want to go back and watch my previous video where I explained about that. But the first thing we need to do is tell the computer we want to print on the upper part of the screen, not those bottom two lines. So we want to specify the code for this upper part of the screen, which is output channel number 2. So I'm loading that value 2 into the A register, and then I'm calling this ROM subroutine, which activates that output channel. And we'll just take a quick look at that down here in my ROM routine section, and it's right here. It's called outchan, and I've assigned it a value that points to the ROM routine that activates the output channel, and that's what we're doing right here. So here in subroutine 3 here, I'm loading a value of 2 into the A register, and then I'm calling the output channel subroutine, which is going to activate that output channel. So it's going to activate the top part of the screen or the upper part of the screen so we can print there. And then let's take a look at what else I'm doing here. So these next lines of code I've explained in detail in the previous video, so I'll just summarize here by saying we need to load the DE register pair with a value of the beginning of our string of text, and we're going to load the BC register pair with the length of our string of text, which is calculated using this formula here, string 1 end minus string 1, and you can see those values in use right here. So string 1 here is a label that comes right before the string of text that I want to print, and you can see here, let's take a look at the string of text I want to print. So here is my string of text stored using these defined byte statements here. And we took a look at this again in detail in our previous video, but let's just review it quickly now. So here I've modified it a little bit to make it very clear for us to understand. So our program is going to call a subroutine in ROM that is going to print all of these characters that I've indicated here. So let's take a look at this first line, which is probably the most complicated line. And what it shows here is it has a defined byte statement that, and then it's followed by a string of characters and codes. So if you look at this first character here, it's actually a label, and it's called underline at. And if we take a look at where I defined that label down here, right here, I've defined underlined at as having a value of 22, because 22 is the control code for the at operation. So I want to be able to specify where on the screen I want to print my message. And so just like you would do in BASIC, you would say print at and then assign certain coordinates where you want to print stuff on the screen. Well, I'm doing the exact same here. So instead of having to remember that the control code for at is 22, I've assigned it to a label that I've called underline at. And the reason I've used underline at instead of just at is because I think that at must be a reserved word in this assembler, because if I erase this underline before it, it doesn't turn pink. So it doesn't indicate that it's an actual label. So I just put this underline before it, and that seemed to allow it to change pink, which indicates that it's a label. So now if we look back at our subroutine, back at our string section here, so the very first character in this message string that I want to print on the screen is a control code that represents the at control. So it's going to tell the computer I want to print at a particular location. And so if you look at this line again, it says at, and then it has 10, 4, which are just the actual numbers 10, 4. And so this is very easy to see what these bytes do. Instead of having code 22 and then 10, then 4, if I've now replaced that code 22 with this label called at, so I can see instantly that this section of data here, these bytes of data, are going to tell the computer to print at location 10, 4. And then what do we have following that is two more labels. One is called ink and one is called yellow. So that is obviously going to be printing control codes that represent the control code for ink, which is going to tell the computer that we want to now specify an ink value. And then my last label here is called YEL, which stands for yellow, which has been assigned a value of 6 right down here. So you can see how I've used these labels now to really make my life a lot easier, I think, when I'm creating this program. And it may seem like it's making it more complicated, but I think it's actually going to make it a lot easier to both modify this program and build on this program and troubleshoot this program. And one other thing that we need to keep in mind is we're not working on the actual computer here. I'm not typing this program on an actual Spectrum computer. So this development environment here and all these characters that I'm putting in, all these messages and all these different notes and things that I'm putting in here, all this extra kind of stuff that I'm including to make it more structured, and more descriptive, all this extra data, all these extra messages, they're not going to take up any more space in my program, because all of these messages and labels and everything, they all get sorted out when this program gets converted into machine code. So the machine code program is not going to contain all my comments, and it's not going to contain labels. So it doesn't matter really how long I make this program or how complicated or how many comments I add. It's not going to take up any extra space in my program. So I think it's really worthwhile to do this, and I'm just going to comment my programs as much as possible to make it as easy as possible to maintain and to modify and to troubleshoot. We're almost ready to run this program, hopefully. So we'll just finish taking a look at this last subroutine here. So we've taken a look at this part of the subroutine, which specifies the output channel as the top part of the screen, and we set up our two register pairs DE with the beginning of our string of data, which is right down here, str1. That's the beginning, and it says here in my message, start of string to print. And then we need to load the end of the string, or sorry, not the end, the length of the string into the BC register pair, which I've done right here by subtracting the beginning of the string from the end of the string using these values here, str1 end, which is right here. And I've used this str1 end label strictly as a marker to have it automatically be converted into a memory location. So here you can see I've used it to store a byte using the define byte instruction, and define byte can either be written in this assembler as DEFB or just simply DB. So here I've just written DB to store a byte of data at this str1 end memory location, and I'm storing a byte of 0, of value 0. And I don't actually need this 0 value in my program, and there's probably a better way to do it, but I'm just going to use the label followed by a defined byte, and I'm going to store a byte of 0, which takes one extra byte of space in my program, but I don't really care. It's only one byte, and it makes my program a lot more easy to understand, I think, for me. So that is how we're setting up our program to be able to call this routine that's going to print this string of data for us. And then finally, that's what we're going to do in this last line here, where we call the print string subroutine, which I've defined down here, right here. Print string label equals 8252. So this ROM routine that prints the string lives at address 8252. And I'm calling it up here by using this print string label. So I'm calling print string, which is the ROM routine to print string. And then finally our return instruction here, it says return from sub3. So this return instruction, remember, every subroutine needs to return, and that's true whether we're talking about a basic program which uses subroutines by using gosub commands. Gosub sections need to return, or if you're using procedures in basic, they also need to return. You should never call a subroutine unless you're planning to return from that subroutine. So that's what I'm doing here. This subroutine has a return statement which says return from sub3, where it's going to return back to, not back to basic, but it's going to return to whatever called it. And what called it was my main program loop up here. So here is where we called it. We, in this line 9 here, call sub3. That's where we call the subroutine, and it's going to return back to the line after this one, which is right here, which is another return statement. But this return statement is the one that returns control of the computer back to basic, because basic is what's calling this entire machine code program to begin with. And that's the entire program. I know that took a long time to go through, and thanks for bearing with me through all that. But programming is a complicated thing. It's not an easy thing we're trying to learn here, right? So apologies if it's taking too long to actually watch all the descriptions that I go through in these videos. But I really want to make it easy for beginners to understand, because I was a beginner in certain areas, and I'm still a beginner in certain areas, including assembly language. And I just want to go through these different topics as I come across them and explain them in as much detail as I think people will need in order to understand them. And speaking of which, I just want to go and cover one thing that I forgot. Sorry, we didn't finish going through this actual section where we're printing our string. So we took a look at the top line here where we're printing our message, and you can see now when we go back and look at it again how easy it is to understand without having to figure out what these different codes work, because now we know what they work. Well, we can see first of all that this section is for strings that are going to be printed, and we can see this first string is called str1, and it is a welcome message by my comment here, and the first line says it's going to be printing at location 10.4 using an ink of color yellow. And in case that wasn't obvious enough, I also have a comment that I put after that that says at 10.3. Now that should actually be at 10.4, I guess. So I'll just change that to 4. At 10.4 ink yellow. Okay. And then the next line says, well, it contains another defined byte statement, which this time has a string of words that say welcome to the dungeon. And then right here you can see I've put a label called CR, and this CR represents carriage return. And so down here at the bottom in my control codes section, and you can see how easy it is to find these different sections and actually modify these sections and add stuff to it, and which is what I did. I originally had a number up there to represent the control code for carriage return, which is number 13, but then I simply added it to my control code section down here, right here. So I've assigned a value of 13 to a label called CR. So now every time I use that label CR, I can use that to print a carriage return. So in this section here where I'm printing the string, you can see this line contains a string of words welcome to the dungeon, and then it's followed by a comma and the CR label, which contains the code for a carriage return. And then in my next line here, I've got another label called tab. And if I go back down to my control codes, I have one, of course, called tab that has the number assigned to it, which equals the control code for the tab instruction. And if we look at that again in my list of codes here, you can see right here the tab instruction has a code of 23, and that's what I'm using down here. I've assigned a code of 23 or a value of 23 to this label called tab. And so now we can see that this line, without even me having to explain it to you now, you can probably guess what this line does. It's going to print at a position where it's tabbing over to column number 1, and it's going to print this message, with any luck you will escape. And then this CR label is going to print a carriage return. And then the next line, you can see, does the same thing. It prints using a tab instruction, then a string of text that contains the letters that spell in one piece. And then it's got another control code here right in the middle of these two strings of text. So in this case, I want to print this in one piece phrase, just regular, not flashing. But then I've kind of inserted a flashing code here, and I've used this flash label down here that I've assigned right here. Flash equals 18, and if we look again at our code, so 18 is right here, and that is the control code for flash. So now you can see how easy it is to program using this method. So all I need to do here is print some text, and then I've inserted this flash, comma 1 code right in the middle of it. And then again, I've changed back to a string of text that says good luck. So this good luck text here, we would expect to be flashing. And then at the end here, I have another label called str1 end db0, defined by 0. And again, we looked at this method in our previous video, but in our previous video, I used the EQU $ instruction to use this label as a marker to this memory address, which indicates the end of this entire string of characters that I want to print, because I need to use this end marker label in my calculation up here, str1 end right here, minus str1. This is the formula I'm using to calculate the length of the string of data that I want to print. So that's why I need to have this marker indicated down here, simply so that I can have this assembler automatically assign a memory address to this str1end label because I need to use it in this calculation up here. Now, are we finally ready to run this program? Okay, it's a good thing I'm not recording this on my cell phone because I'm sure I would have ran out of memory by now. Okay, so now let's bring over the emulator, which is right here. And I'll make it larger by increasing the window size to 300%. There. And let me move this over in case we want to look at the program anymore. Now, before we run this program, if we remember, this is actually a very short program, right? It took forever for me to explain it, I know. Apologies again. But if we look at our main program loop here, this entire program only contains 3 subroutines. And so even if we didn't want to look at all the subroutines in detail, we should be able to tell by looking at the main program loop what this program does. And we can see here, the first thing it does is call a subroutine that sets the border color, and then it calls a subroutine that sets the paper color and clears the screen, and then finally it calls a subroutine that prints our welcome message. So let's go ahead and assemble this now. And I'm saving this program at memory address 35,000, and I've already entered a basic program right here which will call this machine code program at address 35,000 by using this instruction here, randomize user 35,000, which we're all familiar with by now. And then down here at line 999, I've just put a pause statement so that since this program changes the attributes of the screen, it changes the border color and the paper color, and it prints on the screen, and I just want the program to pause after making all those changes and printing all that stuff so that we can see what the entire screen looks like before it returns control back to basic here and prints a message on those bottom 2 lines. And then finally, here's another line that I've entered, line 1000 here, which changes the paper and the border color back to white, which is color number 7, and then it clears the screen. And the reason I've done that is because it's just for testing purposes. Since this program changes the border and screen colors, I just wanted my basic program to reset those colors back to white after every time I tested it so that I could kind of start fresh. Let's go ahead and run this program now, and we'll hopefully see if it works. Run. And there we go. So now, did this program do what it's supposed to do? Well, let's take a look. Subroutine 1, set border color to black. As we know, it should be black. The border is black. It set the paper color to black and cleared the screen, so the paper color is black. And here in subroutine 3, it printed our welcome message in yellow ink, which we specified right here. And you can see that at this line it says it's going to print at location 10.4 ink yellow, which is right here. So location 10.4 is right here. And at our last line, we've cleverly inserted this flashing command here to make this word, these 2 words, good luck, flash. So let's say we wanted to change this program. Now we want to modify it. Well, since we've created in this modular format, it should be very easy for us to modify now, right? So let's see how we could modify this program. Let's say we wanted to have this good luck message printing in red ink instead of yellow ink. So let's see how difficult or how easy it would be to make that change. So let's take a look at our program here. And first of all, where are we printing that message? Well, if we look at our main program loop, right here is where we print the welcome message in subroutine 3. So let's take a look at subroutine 3, which is right here. And now let's see how this thing prints our welcome message. Well, it's going to use our str1 label here to actually find the start of our string. So let's go to our string section here, which is right here. And str1 is right here. So now let's see how difficult it is to change that ink color to red for our good luck message. Well, we can see instantly our good luck message is right here, right? And we've already indicated a flash attribute of 1, so we want this to flash. And now let's add some more attributes to this to change the ink color. And down here we can see we've already set up a label called ink, and we've set up our colors with their own labels as well. So I should be able to just enter the word ink here, and it doesn't matter if it's capitals or lowercase, because when I assembled this program, which I'll do in a moment, I've specified it to not be case sensitive for the labels. So in this particular assembler, and probably other assemblers I assume, we can determine whether we want our labels to be case sensitive or not. So in this case, I don't want my labels to be case sensitive because it's too easy to make a mistake that way, I think. So if I use this ink word now, and then we want it to be ink red, and I'll just turn off the caps lock just to try it out, and I'll say ink red here, but I also need, remember, to separate all these values with commas. So I need a comma here, and I need a comma here, and I don't actually need this space here. So now if I assemble this program, I would expect it to print this good luck message in red ink. It's still flashing, and why don't we even do some more? We'll make it bright. So I'll use the word bright here, and then the value of 1, because if you look down here, I've also used a label called bright right here, which I've assigned a value of 19, which, as we know, right here, value 19 equals the, or is equivalent to the instruction bright. So now, since I've taken the trouble to assign all these control codes and given them their own labels, I can just use those labels very easily in my program. So now up here I can insert this bright label, and that should assign a brightness attribute to this word that we're printing, or this string of text we're printing, and I've assigned it a value of 1 because brightness can only be either 0 or 1, so 1 means it's going to be bright. Okay, so now if I assemble this, and you can see right here, here is the option that I mentioned earlier, where it gives us the option to allow our labels to be case sensitive, which I have that disabled, so I don't want my labels to be case sensitive. And I'll just click OK and assemble this now. And now let's go back to our program, and our program is still showing on the screen here, the output of our program, because remember I have that pause statement, so it's paused. Now I'll press a key to unpause it, and if we take a look at our program again, so now the paper and the border color have been set back to white, which was done using this instruction here at line 1000. So otherwise the paper and border color would have stayed black, but since I inserted this line 1000 here, that resets the paper and border back to white for me, so it lets me easily test my program over and over again. So now if we execute this again, we would expect to see that good luck message printing in red ink, still flashing, but now it's also going to be bright. So let's see if that works. There we go. So it's printing on red ink, black paper, and it's flashing, and I guess it's bright. It's kind of hard to tell whether it's bright or not, but hopefully it is. So anyway, that is how this particular program works. And it's a very small part of this game that I'm making. Obviously, it's just a message saying, welcome to the dungeon. With any luck, you will escape in one piece. Good luck. But I just wanted to show you how I started to create a modular program to start working on this game. Because I think at this point in our journey, we now have enough tools to at least create a basic, well, not basic, a simple game, or at least a part of a simple game that we can get started with. And this is the way I've started my game. So maybe you want to try to make your own game and see if you can at least start to work on a game for yourself. All right, so there we go. Thanks again for watching. I hope you're enjoying this journey that I'm taking to learn how to develop games. And so far, I think it's going well. It's going kind of slowly, but as long as we're moving forward, that's all that matters. And hopefully you're able to start making some small games of your own, or at least starting to begin to make programs that will eventually turn into complete games. So that's it for today. Thanks again for watching, and we'll see you next time.